Okay, so I thought about this failure that we encountered in the previous part of this video. Okay, and I couldn't separate the copper oxalate from sulfuric acid. So I thought about a process which I talked about in the previous video. I didn't have time to do sedimentation at that moment, but now as I waited for like 5 days, it will be 3 days, 3 to 4 days. Yeah. Finally, all of the insoluble oxalate has fallen down out of the solution. So now I can finally extract the sulfuric acid, and I can show you that process and prove that it is sulfuric acid very proudly. Come on, let's go. Okay, so I've taken my internal table for doing chemical experiments, because the air conditioner that has been implanted in my house a few days ago is now working and I cannot open the window. So no problem, we'll do it here. This is also another place for the studio. You can see I've done different chemical reactions here which might have stained the table. Okay, so we'll be keeping our sulfuric acid in this for momentarily. And here is the beaker. I've lost a little bit of yield because most of it got absorbed by the filter. I'll ask the cameraman to lower the camera to show the acid down here. You can see it's a little cloudy here because some of the copper oxalate is sticking to the wall and it is not in the solution. Okay, I'll show you. And also, okay, I've asked the cameraman to fix the angle again. And what I was saying is that you can see most of the oxalate has precipitated out. I was using tissue paper, so most of the acid got absorbed by it, so I have very little yield, but it's okay because I have done the reaction many more times in the past year, and I've got a lot of it. You can see here it's a little yellow. You can see the yellowness even in here. That's because of little bit extra oxalic acid. Okay, so now we are going to do the reaction. You can see, we are going to extract it. You can see that there's a lot of yellowness in here, which you will be also able to see in this measuring cylinder as soon as we extract it. So let's start it. Okay. Okay, I could use my glass dropper, but my glass dropper is a little dirty and I don't want to contaminate this guy. So I'm going to use this one. Or is it this is uncomfortable. Okay, no problem, this one is also fine. This is my trusty glass dropper. Okay, now let's start taking the sulfuric acid inside this jar. Okay, you can see a little tinge of yellow in the acid. I have no other choice except doing this over and over. Okay, final drops have been given. You can see the copper oxalate in here, which is totally blue. I'll ask the cameraman to show it. Let me shake it. Now you can see it's totally blue. It's totally blue. Okay, great. Here is our sulfuric acid yield, which is around the 30 ml mark. Yes. So this is our little yellow sulfuric acid which we have obtained. Its concentration is around 30%, and we need to concentrate it to 98% because this diluteness cannot work, but still it can react with different metals, especially iron, and it can also show different signs that it is sulfuric acid. I'll show you some common signs that it is sulfuric acid. Okay, so the first test we are going to do is the very common base test. Any carbonate or sulfide salt can be added. Any carbonate sulfide salt can be added. I'm adding a little bit of sodium carbonate. Look at the solution below. I'll ask my cameraman to focus at the solution below. I'll add the basic sodium carbonate and it will show effervescence immediately. That's the evolution of carbon dioxide. Great. So first test for acid has been confirmed that this is an acid. Totally all of it has dissolved. Now the second confirmation test is a thin wire of iron. You will be able to see it, I presume. Yeah, you can see it now. Now this is a part of a spring and it should react with the sulfuric acid after a while because the oxide layer needs to go away. So we'll just wait for a few seconds. Okay, I hope you will be able to see the effervescence being done by action of iron on sulfuric acid. Action of sulfuric acid on iron. And see the effervescence. Okay, so you can see hydrogen bubbles being produced by these iron strips. You can see a lot of gas being evolved. Can you? Let me shake it for you and let me focus it for you. See all that is rising? Let me bring a closer look to one piece of iron that is reacting. Can you see the bubbles? It is all being done by Mr. Sulphuric acid, the king of chemicals, which we made. There's a lot of bubble of hydrogen evolution in here. See here. Yeah, you will be able to get a better view. You see all that bubble rising? That is because iron displaces hydrogen from sulfuric acid very easily because it is an active metal, and oxalic acid cannot do that because it is not a strong acid but rather a weak acid. So this is another proof that this is sulfuric acid, and I hope you will be able to know that weak acids, especially when forming insoluble precipitates, form stronger acids. Look at the bubbles. Okay, I know handling sulfuric acid like this, keeping it on your hand is not good,
but I must say that this is sulfuric acid, a little colored, no problem, but we can boil it to concentration. Do not try this at home at all, even if you want sulfuric acid very badly, because it is corrosive. It can destroy you. I mean, destroy, which means delete you from the face of earth. Okay, so do not try to use this thing or make this thing. This is how I made sulfuric acid. Be careful. Bye bye for now. I succeeded finally.